Virtual space travel. In this video, we are going to talk about the origin of the universe itself. Let's get going. So, a misconception people have is that, okay, the Big Bang started out super big and it exploded and then it exploded and then it turned to like a size that was similar to our size, and then it expands super slowly now and it's like going really slow. That is actually a misconception. Actually, the Big Bang started out when it exploded. It didn't really even explode. What just happened is the moment the Big Bang happened, the universe started to expand rapidly at a rate that's actually faster than the speed of light. Because, well, you might be wondering, how can it be faster than the speed of light? That breaks the laws of physics. Well, at the time, everything inside the universe has to follow the laws of physics, but that doesn't mean anything outside of the universe has to follow the laws of physics. So it can go faster than the speed of light in the expansion. And so it is expanded at a certain rate, and it is still expanding at that rate. It is even thought that it is expanding faster and faster every time it expands, even now. That means it is expanding faster now than it did in the beginning of the universe when the Big Bang happened. Also, another misconception that people have is that the Big Bang was super big. It was like maybe it was the size of a solar system, and then that solar system started to expand rapidly, or explode is what some people think. Well, that is actually incorrect. The universe started out super tiny. When the Big Bang happened, it was super tiny. Tinier than an atom. Tinier than what's tinier than an atom. Tinier than that. Tinier than that. From the tiniest thing ever possible. And that's how big the universe was. And suddenly, then, when the Big Bang happened, so imagine squeezing everything we have today, the entire universe, and more, because the universe is not done expanding. Not even close, actually. And imagine all of those things getting squeezed into something tinier than an atom, tinier than the tiniest thing possible. Everything you know of the universe is like everything we have and more. All that, those like the 93 billion light years and a ton of more squeezed into something that tiny. You can imagine how much pressure that is. You can imagine how now you can probably imagine why it had to expand. Because it was so compact, like incredibly compact. So, since that happened, that is why it started out really tiny and it started to expand rapidly at a pace that is faster than the speed of light. And it gets even crazier. If you're wondering how hot it was after the first second, and the first second, it's like the first some milliseconds actually. After that, you would be like, that is every single millisecond. The universe gets so much larger than you can possibly imagine, because the human mind does not grasp these huge numbers. So, the universe was already like so big in the time I'm talking about. And then, after that, scientists believe it is 10 trillion degrees Kelvin. Actually, that was so hot that photons could not travel to us. Therefore, actually, all of this that I'm saying, we have no finalized proof. But we have some evidence, and yeah. So, and it was you can imagine how hot it was. Slowly then, as it expanded, it started to get cooler and cooler. And you can imagine how it would be this hot, even hotter when it was squeezed all of that. And soon, so slowly, the universe started to expand, and, well, not really slowly, but it started to expand, and over the billions of years, over 13.7 million years, we are here now. and the universe is still expanding at the same pace or even more. And the universe is getting cooler still. The universe is decently very cold because of the 13.7 billion years. Alright. Thank you for watching this video, and don't forget to like, subscribe, and hit the bell.
Subscribe!